Hi everybody, welcome to the next session on the developer track. This session's on VMware advanced capabilities. So if you were expecting a talk on monitoring CloudStack with Prometheus, you're on the wrong track. You need to go and find the other room. So this talk's presented by Nicholas and Harry. So everybody please give Nicholas and Harry a warm welcome. Over to you, Harry.
Oh, thanks, Giles. Hope everyone is enjoying their sessions, and hope you will enjoy this session too. So this is about VMware or vSphere advanced capabilities. So myself, Hari Krishna, and my co-speaker Nicholas will be sharing this presentation. Before going to the actual content, a quick background of ours. So we work for Shablue. I as a software engineer, and I'm based off of India. And I have 9+ years of experience, almost on CloudStack since 2012, and I hold a committership in this project. And my colleague Nicholas, he's a senior software engineer. He's based off Uruguay, having same 9+ years of experience, and he's into CloudStack since 2015. He is a committer and PMC member too. That's cool. Going further, this is our agenda to cover all the topics. Basically, this advanced capabilities is divided or developed as part of two features. One exclusively covers storage advanced capabilities, which I'll be presenting the new storage types, storage policies, and using vSphere's native APIs. Nicholas will be covering the other part, which is support for virtual appliances. He'll go in detail of how OVF format looks and how this support is added into CloudStack with all these details. So I'll start with my content, which is storage advanced capabilities. As part of this, we have got many new things added into CloudStack, starting CloudStack 4.15 version. So one of them is support for the new storage types. So basically, we are covering all the storage types which are supported by vSphere into CloudStack as well, which covers VMFS6, vSAN, vVOLs, and Datastore cluster. So the next storage technology that is also supported in CloudStack is vSphere storage policies. I'll cover this in detail in the next slides. The other interesting part, actually the main part of this feature is using the native APIs of the vSphere. So CloudStack now uses all the storage operations by calling the native APIs of vSphere. Actually, this makes CloudStack easier to support the new storage types, because when we use the native APIs of vSphere, it doesn't matter what storage type it is. That made us easier to add the support for all the storage types. I'll go into further details of storage types. So prior to CloudStack 4.15, we have these storage types, NFS and VMFS5 for primary storages. Along with them, now we have VMFS6, vSAN, vVols, and Datastore clusters. So this is our old UI. If you can see, this is the add primary storage dialog. Under protocol, we only have NFS and VMFS. With these new advanced capabilities, under protocol, as usual, we have the NFS. We have the new protocol types, Presetup and Datastore cluster. So we don't have the VMFS. Even we don't have the storage types VMFS, vSAN, VVOLs. We only have Presetup and the data store cluster. So to go a bit detail about what this Presetup protocol type is, so since we are using all storage operations by just calling the native APIs of vSphere from CloudStack, it does not matter what storage type it is. Any storage that is already preset upon vCenter that can be directly added into primary storage without having to specify that storage type. So presetup covers all the storage types: VMFS5, 6, vSAN, VVOLs. Once it is added, CloudStack will detect the storage type and adds it to the database just for readability purpose. Otherwise, any storage type is presetup. We have a different storage type, data store cluster. This is made because data store cluster is also one of the storage technologies in vSphere, but this is a bit different when compared to the other storage technologies, because data store cluster is a collection of data stores as by definition. But to the end user or the admin, data store cluster is a single entity, as in we add into CloudStack as a single entity. Say suppose if this is a screenshot of the vCenter. See, we have a data store cluster and there are two child data stores in it. So we just need to add this data store cluster into into CloudStack under primary storage as a single entity. We don't need to add these two primary storages. So we just need to add the data store cluster here. CloudStack will auto detect the child data stores, and they also be added into CloudStack, but they are all hidden. To the admin, we'll show only data store clusters. Any storage operation are done on that data store cluster itself. The other interesting part of the data store cluster is on vSphere, data store cluster supports storage DRS, which is a very important part of data store cluster. So since we are supporting data store cluster as a primary storage here, which in turns add ability of storage DRS into CloudStack. So anyone wants to use the storage DRS, they can do it with data store cluster. Going forward, this is about vSphere storage policies. By definition, again, vSphere storage policies are very similar to the disk offerings. Basically, vSphere uses storage policies to the best placement of their disk images. So in CloudStack, we use storage tags in disk offerings. Say, suppose if I want to create disks in a storage which supports encryption. So all I have to do is I have to select a storage policy in vSphere, say suppose VM encryption policy. So when I create the VM or when I create a volume, I have to select the corresponding storage policy so that that disk or volume will be created into a storage which supports encryption. So so like I said, since this is very similar to the storage tags into CloudStack, we have integrated into CloudStack into compute and disk offerings. So whenever we create a compute or disk offerings, we get to choose what storage policy we need to select. Say suppose I'll quickly show you like how this storage policy can be added into a offering in short time. So any storage policy that are created on vSphere, that we have to import them into CloudStack to map it to a corresponding compute offering or a disk offering. For it, we have these new APIs: import vSphere storage policies, list vSphere storage policies, and this list vSphere storage policy compatible pools. So these are all just to manage the storage policies that are already created on vCenter. So another thing is we don't have to actually import them manually, but when a vSphere data center is added in CloudStack, at the very first time it will auto import the existing storage policies. Later on, if there are any changes on the storage policies at vSphere, if we use this API, import vSphere storage policies, they will be auto imported into CloudStack. So that's all about the storage capabilities. I'll quickly show you what I just spoke about, all the storage types and the storage policies. So I'll start with the storage policies because I just spoke about it. So under disk offerings, if I have to create any disk offerings, once I select any zone, here we'll get an option to choose any of the storage policies which will be tied to the created disk offering. Say suppose if I create a VVOLs related storage policy, any disk offering, any volume that is created using this disk offering will be created only on VVOL storage type. The same thing is available with the compute offering as well. This is basically for the root volumes. This is about the storage policies. About the storage types, as I said, we have NFS, Presetup, and Datastore clusters as the primary storages. So whatever we select on the Presetup, any Presetup storage type that can be added here. I have already added bunch of primary storages with different storage types. If you can see, all of these are NFS. These work as usual. So these are the new things that we have added. These are all added VMFS6, VMFS5, vSAN. These three are added under protocol type presetup itself. Once they are added, this type is auto-populated from vCenter into CloudStack. And this is a data store cluster. As I said, we'll show this data store cluster as a single entity. I mean, as a single primary storage in CloudStack. So whatever, how many child data stores are there in the data store clusters, we don't show them. We only show this data store cluster as a single primary storage. But any changes that happen on the on this data store cluster, say suppose, so this is the data, this is the vCenter, and this is the data store cluster which we have added. We have two child data stores here. If I have to add any new child data store into this data store clusters, we can do that from vCenter. But we also have to sync that data into CloudStack. How we do that is by using sync storage pool API. So we have this option in UI as well. So when we do this, so any changes happen on the vCenter with respect to any new child data stores added, or if any child data store is removed from this data store cluster, those will be synced accordingly with CloudStack. So that's the option we have with this sync storage pool. All other operations on the storage, they continue to work as it is, like on whatever the storage type it is. The improvements that are done as part of how they were implemented, I mean using the native vSphere APIs, so those continue to work as it is, but with more efficient way, since we are using vSphere APIs itself. So that's about it. Maybe I'll take up the questions at the end, maybe after Nicholas talk. Nicholas, I'm stopping my screen share.
Thank you, Harry.
Yep.
Yeah, please. Then I can share mine.
Yep. All yours, Nicholas.
Thank you. One second. Somehow it's not working. Can you see it?
Yes.
Okay, good. So welcome, I'm Nicholas. This is the second part of the talk. So the second big change introduced for the VMware code base was the taking advantages of what VMware templates offer. So usually these OVA templates contain more information that CloudStack could not handle before. For example, the use case of virtual appliances is a good use case that is now supported by CloudStack as well. So from vSphere, administrators could simply import an OVF file into a data center, and that is also supported in CloudStack now. So very briefly, I will talk about the OVA templates, which they contain the VMDK files, the manifest file, and also the OVF file, which is a very important file for CloudStack because it contains the description of this file in an XML format. So here is an example of an OVF file, which CloudStack reads after downloading the template, and it parses each section. So for example, we have highlighted the disk section, and this example has 2 disks, and the deployment option sections, which are deployment configurations, it has 3, which will then present to the user in the VM deployment wizard. So basically, CloudStack now registers the template and extracts that information from networks, disks, properties, and license agreements if they are available in the template. So from the CloudStack point of view, this is a new setting which is enabled when registering the template, which is read settings from the OVA. It is an optional mode which does not change the default mode for the previous VMware templates. It's just an optional mode. And the user does not have the option to select the root disk offering or NIC adapter or even the OS, because CloudStack will handle all of that and will read it from the OVF. So I'm sharing now what it looks like before, or with the default mode at the left of the screen, which is the normal template registration in VMware. And you will see the read VM settings checkbox, which is not ticked. Then you have the options to select the root disk controller and other properties. But by simply selecting the read VM settings from OVA, then all this information gets hidden, and it allows to register the template very easily. So this is what CloudStack will parse that information from the OVF. In this example, this is an example, but there could be another sections as well. And in the VM deployment wizard, then the users will see the deployment options, if there are, in the compute offering sections. So the compute offering section will filter all the compute offerings that will match those requirements from the deployment options. Then if there are multiple NIC adapters, then the user will have the option to plug it to different networks, depending on what's defined also in the OVF file. And this is also from vApps, which is the vApp properties, which are configurable properties for each appliance. So CloudStack will also present it. I'm going to show you that in a minute. It will present it in the VM deployment wizard if it is available, and will allow users to populate these values accordingly before doing the deployment. And also, oh, sorry, the license agreement picture was not updated, but it is also needed to, it needs to be accepted before continuing. So I will show you now here what it looks like. So I have registered some templates for this example, vCenter 7, vCenter Server Appliance, and a few other templates, which the deployment wizard will allow you to select the template, and in case it has different configurations, those will be listed on the compute offering drop-down menu. All these deployment options are for the vCenter appliance, and it will auto-populate with the memory and CPU that it's needed. This will be need to be overridden. For example, this template is also registered in that mode, but does not contain any deployment options. So those are not displayed, and the compute offerings are displayed as normal. So then, for example, the other template as well contains 3 configurations, which are listed. And in this case, the number of networks depends on the template selected. I'm going to select this one, for example, and the number of networks change as well. And now this section is also optional, the vApp properties. And these are also as well dependable on the template. I'm going to select another template which does not contain that section, so it's not displayed. And lastly, the license agreements, which the user must accept before deploying. And yeah, the user is able to follow all these steps that are that can be done through VMware, and it was not possible before, so it's now able to do it in CloudStack. So going back to the slides, that was a very short demo. We had left some references in the slides for people to read more about those features. And as a conclusion, yeah, CloudStack is now extended to take more advantage of VMware and its advanced capabilities. We have introduced multiple storage types. We have introduced the use of storage policies, this new template registration mode, which allows you to read and honor the OVA template and importing it, and also the support for virtual appliances. So that's it for it, and I'll open for any questions that you have.
Nicholas and Harry, thank you for that. Thank you for that. Oh, we have got a question. I was about to say you got away scot-free and there weren't any questions at all, but there's some questions. Here we go. When will this stuff, I'm sorry, Darren, I'm paraphrasing you here. When will these expanded support vSphere land in CloudStack? When is it available?
So should I answer, Harry?
Yeah, please go ahead.
So we have these already supported in CloudStack since version 4.15. And yeah, also 4.16 has some improvements around the second part, around the OVF import. So yeah, 4.16 is a more stable version, but 4.15 also includes it.
So I think that's a consequence, Nicholas, of not having a conference in 2020. You would have probably talked about this then, right?
Yeah.
Okay, thank you. Darren, hopefully that answers your question. Suresh has asked, can the same deploy as is template be used to create a VM with custom settings for disk controller, NICs, etc.?
So no, what you can set your template and what is defined on the template then will be imported in CloudStack. So that's a restriction to the previous use of the VMware deployment mode, where one can set the settings. That is not allowed with this because it honors what is set on the template.
Guys, sorry, of all days, my DSL's playing up here at home. I don't know if you can hear me.
Yes.
Give me a nod or a shake of the
Yes,
head.
we can hear you.
Yeah, great. So everyone can hear me, and I can't hear anybody. That's perfect. So this is a general question. What's the advantage of Apache CloudStack comparing it with VMware vSphere or VMware vCloud Director? I'd love to jump in and answer that, but I'm going to let you guys handle that because it's your session.
I think you can answer it in a better way, but maybe I'll put my 2 cents here. Yes, we can do like whatever we can do with CloudStack, we can do on VMware as well, but there are a lot other bunch of things in CloudStack, whether it is account management or network management. It's not just about the VM deployment or the storage management, but it's all cloud related things. So maybe Giles, if you want to add something more to it.
Giles?
Yeah, thank you, Harry. Dan said, are further improvements to be expected? So what's next, I guess?
With respect to the storage advanced capabilities, we have pretty much there, like whatever the storage types and storage technologies are there on vSphere or VMware, we already have them. With respect to Datastore clusters, actually we have found a couple of issues and we have already fixed them in 4.15 2 and 4.15.1 releases itself. So with respect to storage capabilities, it's all up to date.
Yeah, and
Okay.
with respect to the deploy as is mode, we have also some fixes in 4.16, but of course, as the feature allows the templates to be imported as it is, so there could be many features or some features that should be supported and are not supported that we are not aware of now, but those could be extended as well.
Okay, the next question is from Abhishek in relation to storage migrations in CloudStack. Are there any differences when dealing with Datastore clusters when we're talking about storage migrations? Sorry, VM and storage migrations in CloudStack.
Yes. Actually, thanks Abhishek for asking that. I have not covered that part. But with respect to Datastore cluster, as I said, once it is added as a primary storage into CloudStack, it's a normal primary storage. So any storage operation, whether it is volume or VM migration, that work as normal and as expected, like the other primary storages. But the thing is like how CloudStack manages the storage DRS in Datastore cluster. If say if we want to migrate a volume from a Datastore cluster to a different primary storage, say NFS, since storage DRS is enabled on the Datastore cluster on vSphere, that volume can be migrated across the child data stores within the data store cluster. But CloudStack has to detect that storage DRS is applied on that volume, and once that before the migration happens, it will sync that data of that volume into CloudStack and then performs the migration. So whenever that migration happens, CloudStack will make sure it has the proper data with it and then starts the migration. So there won't be any issues or any differences in handling those migrations. It's just that CloudStack will try to sync the data and do the operation migrations. Yep.
Thank you, Harry. We've got another question. They're coming in thick and fast now. Ray has asked, any tips you can give for providers planning to deploy CloudStack over an existing vSphere cluster? Any pain points, concerns we need to plan for in advance? I know that's probably beyond the scope of this very specific talk, but guys, if you've got any insight on that, that would be useful.
Well, so the existing cluster can, with the use of CloudStack, you can make use of the good features that CloudStack has. Not covered in this talk, but was introduced previously. We have introduced the VM ingestion feature, which is really nice, and you can make use of that in your existing cluster. Can import the virtual machines directly into CloudStack. So that should be a good feature to use, and of course these new advanced capabilities as well.
Cool. Harry, any thoughts on that?
That's about it. Nothing much to add from me.
Okay, and Suresh has asked another question. At what point CloudStack detects the volume migration within Datastore cluster by vSphere?
Okay, I think this is related to, again, storage DRS within Datastore cluster itself. So so once the volume is deployed on a Datastore cluster, it can be deployed on any of the child data stores. Since storage DRS is already applied on it, that volume can be migrated on the vSphere itself without CloudStack's knowledge. So when a volume, so CloudStack will not poll vCenter to sync the volumes data. It's not a continuous job, but whenever an operation is performed on that volume, say suppose if we want to detach a volume from the VM, or if we want to migrate the volume, at the time of operation, CloudStack will try to sync the data of that volume where it is on the child data store. That's about that. It's not a continuous process, but whenever we do a volume operation, then we sync the data.
Okay, thank you, Harry. So that looks like just about all of the questions, guys. Unless there's any last questions anybody wants to ask before we finish, ask now. We're going to go. Okay, so massive thank you, Nicholas and Harry. Really good talk on some great functionality. Everybody, please give the guys a virtual round of applause or a virtual thank you. It'd be appreciated. Next talk is a workshop actually at 1:30 in about 15 minutes on Cloud MC, which I'm quite interested to see. And then after that, in an hour later, there's a networking lounge. So everybody, thanks for listening to this session. Thank you, Harry. Thank you, Nicholas.
Thank you.
Thank you.
Thank you, Giles.